Okay, so this is episode 3 of, Learning Target 11.1 videos. And what we want to do is we want to go ahead, given a statement, we want to be able to set up a null and alternative hypothesis for that statement in symbolic form. All right? So, what we're going to do is we're going to make a statement that the average human body temperature is not 98.6 degrees. That's our statement. Now, you always set up, first of all, part A of your process of steps would be to identify what population parameter we're talking about. Well, again, the average human body temperature, we're talking about average, so we are talking about a population mean, okay? Now again, all of those are going to, in this target, are going to deal with population means, but again, if you were to, you're doing some research on your own, or you were in another class, you're in a statistics class, you'd have to determine, is this a proportion, an average, a mean, or a standard deviation? So these are all going to be means. Now the second, part B of your process of performing a hypothesis test would be to set up the null and alternative. Well, we always set up the null first, and here's how we write it. We H, and then some 0, and then I put a colon there. Now remember, the null always contains the condition of equality, so we're going to put the mean is equal to 98.6 degrees Fahrenheit, okay? Even though we're saying we think that we're going to test that the average human body temperature is not 98.6, the null is always the assumption that of equality, that the mean, standard deviation, proportion is equal to some value. So then the alternative comes from this statement is we believe the temperature is not 98.6, so we're thinking it either could be more than that or less than that. So we would say the mean is, population mean is not equal to 98.6 degrees Fahrenheit. So again, ladies and gentlemen, the null, this is the null hypothesis. You don't have to write this part down. This here is the alternative hypothesis. Okay? Always write the null first, the alternative second. So let's go to the next problem. It says here the average salaries of first-year teachers in a school is more than $39,900. Well, again, we're talking about an average, so we're talking about, again, a population mean. That would be part A. And then part B would be set up your null and alternative. Well, our null, again, is the condition of equality, that the mean is equal to the average teacher salary is equal to $39,900. So how do we set up the alternative? Well, it's based on this. The claim is that it's more than that. So the claim is that the alternative is going to be that the mean average teaching salary is greater than $39,900. See, this isn't too bad once you get the hang of it. And that's all you need to write down. So let's go look at the third one. And maybe on this one, try this on your own first. So pause the video, read through it, and see if you can do it on your own, and then we'll come back and we'll look and see if you get it right or not. But federal law requires that a jar of peanut butter that is labeled 32 ounces must contain at least 32 ounces. A consumer advocate group feels that a certain peanut butter manufacturer is shorting customers by underfilling the jar. So the consumer advocate group feels like they're underfilling, meaning they're filling them with less than 32 ounces. That's what underfilling means. So again, we're looking at an average, all right? We're going to collect samples of these from this manufacturer of the 32-ounce jars of peanut butter, and we're going to see how, on average, what's the average of that sample. So this again involves a population mean. And so our null hypothesis, the mean, the average amount that those sample jars are going to be filled with is always equality, 32 ounces. Okay? So what's the alternative then? Well, they want to test to see if they are underfilling, meaning they're filling them with less than that. So we would just go less than 32 ounces would be our alternative. And then, of course, you collect your sample, that's a hypothesis, of however many jars you want. You find the amount in each jar, you average for that sample, and see how does that average compare to what it's supposed to be, 32 ounces. All right? Now somebody's going to say, what about this at least? That's just telling you that the jars are supposed to be filled with at least 32 ounces. What the group wants to see is, are they underfilling? And that's what we're going to do our hypothesis test. So that's it for the examples 1 through 3. And what we're going to start looking at is other parts of the hypothesis testing process, like significance level and test statistics and so forth. Okay? So I'll be in the next video.